Woohoo, and welcome back. Today, Godzilla and I will be working with you on new types of exponents, specifically what happens when we've got exponents that are equal to zero or to negative integers. Dun dun dun. So, in order to start this, I am going to take a look at a pattern. And the pattern is going to start with 2 to the fourth, so 2 to the fourth power, which equals 2 times 2 times 2 times 2, which equals 16. And then I'm going to say 2 cubed. 2 times 2 times 2, right? There are 3 of them. And that equals 8. And now what I'm going to do is, instead of just keeping going, I'm going to set up a pattern. I want to observe what's going on. So over here, the exponent decreased by 1. And over here, well, we could look at it a lot of ways, but the way I want to look at it that's going to help us out is that to get from 16 to 8, our answer was effectively cut in half. So in other words, I divided by 2. Okay, let's see if this pattern sticks. So I'm going to go to 2 squared. Now that is decreasing the exponent by 1. It's 2 times 2, which equals 4. When I go from 8 to 4, am I also dividing by 2? And the answer is yes, I am. Woohoo! I've got a pattern. Let's see if it sticks. So next up, I'm going to go 2 to the first power. I have decreased my exponent by 1. Now this is just a single 2, which is just 2, but that is 4 divided by 2. So the pattern is holding. At this point, I'm going to kind of go way off script because, well, I don't actually use a script, but I know you can't tell the production value is very high on these videos. I'm going to go ahead and decrease the exponent by 1. So now I'm going to get to 2 to the 0th power, which I will claim does not have a physical representation. Not in the same way that these do. The 2 to the 4th means 2 times 2 times 2 times 2 4 times. 2 cubed is 2 times 2 times 2. 2 squared is 2 times 2. 2 to the first power is just one of those 2's. And 2 to the 0th power, who knows what that means? It means no 2's. And what is that equal to? And a lot of people say, well, that should be 0. And I can understand that. That is a very appealing suggestion. However, it doesn't fit the pattern. The pattern is actually that whatever this number is, it should be 2 divided by 2. We want to keep this pattern going. And so we're going to make it equal to 1. And I know if you have never seen this before, if this is brand new to you, you're going to be like, what the what? Because 2 to the 0th should not equal 1. It should equal something else. But it turns out that this pattern, that 2 to the 0 equals 1, doesn't just fit this pattern, it fits a lot of other patterns. It actually seems to make a lot of sense. And it's kind of that keystone that makes all the math work together. So this is now possibly the first time you may have experienced a truly abstract concept in math where we've got this notation, which someone came up with to be representational, and we're using it in a situation where we can't be representational. How do I draw 0 2's? It's kind of a strange question to ask. But that we actually can find meaning in it according to the pattern. And you're going to discover as you go on in math that there are a lot of times when we will look at patterns to help us figure out what something should equal. And I'm not going to argue with you. It's very hard to imagine what 2 to the 0 might represent, but it absolutely does equal 1. And in fact, a to the 0 equals 1 in all cases as long as a itself is not equal to 0. It turns out that 0 to the 0 is undefined. And if you're not sure why that's true, we don't have to look much further than this pattern, because if your base is 0, then each of these steps would have to be divided by 0, which is, it blows the whole thing up. So I can kind of appeal to you from that perspective. This particular pattern would lead us to believe that we can't play with 0. And it's true, 0 to the 0 is undefined. And it turns out this isn't the only way to explain this. It's just the one that I like the most, because it's the easiest way to see it. But this does come up in a lot of settings, and this has been known for a very long time, and it has been well tested, and it actually is very robust. So this is absolutely true. As long as a is not equal to 0, any base raised to the 0 power is 1, which leads us to the easiest homework ever. 3 to the 0 equals 1. Pi to the 0 equals 1. -5, the quantity raised to the 0, equals 1. And before you start going 1, 1, 1, 1, 1, -5 with a 0 is actually -1. Oh, there's always got to be 1. That's just a pain, right? So why? Why is -5 when -5 in parentheses to the 0 is 1? Well, the answer is that if you write -5 to the 0 like that without parentheses, order of operations tells us that the minus gets left out of the party. Exponents only, they're very nearsighted like I am. They can't see very far. And so a 0 sitting here only sees the 5. It doesn't affect the minus. The minus gets left out. And so you end up with a negative on the outside and 5 to the 0. So that's the opposite of, and then 5 to the 0 is 1. So that's why that works. So be really careful. The difference between these two is significant. If the whole number with the sign included is in parentheses, then the whole thing raised to the 0th power equals 1. If the minus is left alone, the minus wanders off and it's just -1. And then, of course, number 5, 0 to the 0th power is undefined. Woohoo! Yay! Life is good. So even if it's a little weird, hopefully it's kind of nice. A nice break from having to do a lot of calculations. Okay, so next up, we're going to do the same thing, but we're going to keep going. So what does that mean? Well, I'm going to start with 2 squared. 2 squared is 2 times 2 equals 4. Great. 2 to the first, right? We've got that pattern. The exponent decreases by 1, and that's just 2. And that equals 2, and then okay, we've been here, right? Been there, done that, divide by 2. Okay, now we know 2 to the 0th, now that we know from the previous page, that's equal to, we don't know what, but it equals 1 because of the divided by 2, but we're not going to stop there. We're going to keep going. 2 to the -1, so I'm subtracting 1 each time. This, again, what is the sound of one hand clapping? What is the value of -1 2's multiplied together? It doesn't make any sense. So I'm going to claim that this does not have a representational meaning in the same way that these two do. It's much more like the 0th power where we're following a pattern. However, I can figure out what it should be. I'm going to follow the pattern. So, and now I know that there's a sudden groan from the audience as everyone realizes the true horror, which is that fractions are everywhere. I know. The more math you do, the more fractions. 1 divided by 2 is 1/2. Dun, dun, dun. And we're not going to stop there. 2 to the -2. Because you can't, and you won't, and you don't. What? Stop. Exactly. We don't know what that represents, but we can follow the pattern. Now, at this point, I know people are going to be like, wait a minute, shenanigans. How do I divide 1/2 by 2? And you can. It requires reciprocals, and it's shenanigans. But I'll remind you, dividing by 2 is multiplying by 1/2. So this is going to be 1/2 times 1/2, which is 1/4. Which, okay, that's fine. But now I'm going to write something interesting. That's 1/2 squared. And then I see a new pattern. 2 to the negative 1 is 2 to the first power, but in the denominator. 2 to the negative 2 is 2 squared, but in the denominator. Next one, we subtract 1, so we get negative 3. Don't know what it represents. I don't know what multiplying negative 3 2's together would be, but I know that this is going to be the previous answer times 1/2, which is 1/8, which is 1/2 cubed. Wait a minute, I see a pattern here. Negative 3 means the exponent is, the whole thing gets dragged into the denominator. And so I'm going to reach up, because I forgot to grab it before the video, but he's right here. I'm going to introduce you to blah blah, the sparkly vampire, because you know all vampires sparkle. Look at that. I'm pretty proud of this one. Okay, so what do sparkly vampires and Godzilla have to do with exponents? Well, they don't really have anything to do with exponents. And in fact, Godzilla is here just as my support carnivore. But, or actually omnivore. You know, if you eat a city, you're eating everything. So not so much a carnivore, an omnivore. But what do vampires have to do with exponents? And the answer is, where do vampires like to live? They like to live in the basement. So if you've got a negative exponent, you don't really have a regular number. You have a vampire number because it wants to live down in the denominator, in the basement. Woohoo! Okay, so let's take a look at this. These rules. And again, as usual, I feel compelled for whatever reason to write these rules out, even though I know full well that looking at these make a lot of people's eyes just spin around in their heads. But I'm going to start here. So let's take a look. Let me see if it makes sense. And know that the very next page is going to be me going over examples. So for any non-zero real number a, so a cannot be 0. And n is an integer for now. I know, there are going to be more shenanigans later on. And n gets to be whatever it wants, really. But for right now, n is an integer. Then if you have the opposite of n as an exponent, that means that a to the n is in the denominator. But also, if you have just plain n as an exponent, then the opposite of n is in the denominator. And so basically the rule is a negative exponent means you're in the wrong place. That's where I'm going to go with this. Okay. Plus, if all of that is like making your eyes spin, I'll say, ooh, look at the shiny, shiny. Isn't that beautiful? Look at how that shines. It's so pretty. Okay, so one of the things we like to do when we're just practicing with exponents is that we just take expressions and we rewrite them. So make sure that you feel confident writing things in different ways. All numbers. I'm just going to say it, all numbers, even though my brain is like, well, all numbers? I think all numbers can be written in multiple ways. So we're going to go ahead and look at a few ways to just, it's like translating. So first one, 5 to the negative 2. Negative exponent. That tells me not happy where it is. There are two places you can be. You can be a regular person on top, or you can be a sparkly vampire in the denominator. This is secret vampire. Okay, not so secret. So we've got 1/5 squared, which then means, well, it's just 1/25. Normally 5 squared would be 25. 5 to the negative 2 means it's 25 in the denominator. Okay, 3 to the negative 1. Oh, not even as hard as the first one. It's 1/3 to the first power. Again, another vampire. Okay, 1/3. Now this is where things get exciting. 1/4 to the negative 2. Is that a happy exponent? by which I mean, is this a positive exponent or a negative exponent? This is a negative exponent. If the exponent is negative, that base is not happy where it is. It's in the basement, right? The basement. I know. Sorry, I had to do that. It's in the basement, but it doesn't want to be. It's surrounded by vampires. Is it happy? No. Let's make it happy. And what happens when you move your base with the exponent, you change the sign. See, when we had 3 to the negative 1, it became 1 over 3 to the positive 1. So when it changes where it is, it changes, right? Change your apartment, change your life. So suddenly 4 and 2 are very happy. And 4 squared is just 16. And 16 over 1 is 16. So this was unhappy in the denominator. We brought it up top. It's happy again. Okay, negative 2 raised to the negative 2 power. There's a lot going on here. The good news is we've got parentheses around everything. You know what? Don't worry about these. I know they're very distressing, but don't worry about them. We'll get to them when we get to them, and then we'll deal with them, and then they'll be fine. So we've got parentheses, which means the negative and the 2 go together. They stay together. Wherever the 2 goes, the minus goes. Is it happy? And I look right here and I say no. The exponent is negative, very unhappy. So first thing I'm going to do, make it happy. I know. You could do a lot of therapy on me based on how I teach math. Exactly. But that is going to be our goal. We're going to work on helping all the numbers to feel happy. So I moved the negative 2 down into the denominator. Notice that the exponent changed sign. I used that to move it. And then I think to myself, okay, I've got negative 2 squared. And because there's a minus involved, I am going to write it out this way. I don't trust myself otherwise. And I think to myself, I don't have my Bat Brothers here, but I can use it with my hands. 2 minuses make a plus. So there we go. We get 1/4. So far, so good? And I'll remind you, I'm just doing basically a review here. If you need more, you're always welcome to ask me for more help, more explanation. You can always ask the tutors. They love this. I don't know if they have sparkly vampires. They probably will just explain it with math and not sparkly vampires, but that's okay. We'll always have the sparkly vampires. Okay, dun dun dun. You knew it had to happen. Oh, I know. What fresh mess is this, right? So, what we now know is that even though this minus is written right next to this 2, they're not actually together. The parentheses hold them together. No parentheses, they run wild. And so what we've got is we've got a minus that hangs out by itself, right? This minus right here is going to be just hanging out. And then we're going to be looking at 2 to the negative 2. Okay, so that's going to be a minus. And then what's happening in here? 2, happy, not happy, not happy. It's a vampire. You know it. Sparkle, sparkle. So let's move it into the denominator to make it happy. Aw, isn't that great? I love happy vampires. They sparkle. Sparkle, sparkle. Okay, so then I've got 1 over 2 squared. Woohoo! But there's a minus out in front. So I've got minus 1 over 4, and we're done. Woohoo! Notice the only difference between this problem and this problem is that this one's positive 1/4 and this one's negative 1/4 because the minus doesn't get squared. The minus is left out of being squared, so it's just a single minus. And, it's just like, baby bats. If you've got 2 of them, they're happy. But when there's just 1, it stays sad. I know, it's a sad story. Okay. Dun, dun, dun. So even when you've got an expression with a bunch of things written next to each other, the different parts of that expression can end up being humans or vampires. And you just deal with it. So what does that mean? I've got 12x cubed y to the negative 6th. And I'm going to ask you, is the 12 happy? If it's happy, leave it there. Is the x cubed happy? Yes. Positive exponent, x cubed. Is the y happy? No, the Y's really not happy. So let's cheer it up. Let's say, hey, look, I'll dig you a basement. Happy vampire. Y to the negative 6 becomes 1 over y to the 6th. And that's it. That's all you have to do. Nothing cancels. And it's just really, look at them all being happy and sparkly like that. We could have a sitcom, right? The humans upstairs, the vampires downstairs. It would be hilarious. Okay. Dun, dun, dun. I know. The last one always escalates quickly, doesn't it? The last one, it's like, I'm like, oh no, I need to terrify them. Okay, so there are multiple ways to approach this. My first step is almost always to rewrite the problem, just to make sure I understand what's going on. And then I'm going to say there are a lot of ways to deal with this. And I am teaching you a bit of a shortcut. And if you would like to know the full, horrible, persnickety details, come talk to me. I'll show you how to do it the real way. And I will show it to you and you'll say, oh, that makes no difference. And I say, yes, that's why this shortcut is really good. I love shortcuts when they don't change the outcome of the problem. Shortcuts when they make the problem work out kind of wonky, no, I won't use those. But this one, it'll work fine. So basically all we're going to do is we're going to go through, give ourselves a really big apartment building, and then we're going to say A. A is happy? Yes. A is a to the first. B is happy? No. B is so sad. Look at B. So sad. B is a vampire. Let's write it downstairs. Once you bring it downstairs, it's happy. C to the fourth, happy? Yes, leave it there. D to the fifth, happy? Yes, leave it there. F to the negative 2, oh, sad, sad, so sad. Put it upstairs. It wasn't a vampire. It was actually a person. It was just scared of being downstairs in the basement with all the vampires. So it turns out that everybody ends up staying basically in the same place unless they have a negative exponent. If you have a negative exponent, then you're in the wrong spot. So write yourself in the correct spot. So the B and the F switch places, everybody's happy. Woohoo. Okay, you guys ready? Are you sure? We got one more page. We can do it. Okay, let's do it. Woohoo. So what happens if I am working with negative exponents and then I'm trying to use, all the properties we have before? And the answer is, it's really great. All the properties are exactly the same. So if I've got two matching bases, right, 5 and 5, and I've got two exponents, and I'm multiplying, I add them. So I get 5 to the negative 2 plus 4. You just add them straight up as numbers. And then you get 5. What's negative 2 plus 4? 2. 5 squared. That's it. Whoa. Now, what about the division? Well, here's where you get a couple choices. I find that a lot of people, when they're working with fractions, they prefer to move things, like we did in the last problem on the previous page. Let me see if I can grab that quickly. Like we did in this problem, just move everybody until it's happy. So that's method 1. And I won't memorize these, so you don't have to know that this is method 1. I'm just saying it's the first way we could do it. So don't worry about memorizing method 1 versus method 2. It's just something I'm saying. So what we do is we say 5 to the negative 2 all over 5 to the 4th. Who's happy? Who's sad? Well, the 5 to the negative 2, not happy. So that's going down the denominator. But the 5 to the 4th is already happy down there. Now, if you move everybody, who's left? Just a 1. Not a 0. Remember that. When you're moving things like this, it's basically canceling. So make sure you leave a 1. Okay, but now I've got the usual. This is 5 to the 2 plus 4. So that means it's 5 raised to the 6th power. 1 over 5 to the 6th. And let's see. Oh, you know what I didn't do up here? 5 squared is 25. I don't remember what 5 to the 6th is. I should have this memorized. Oh my goodness. Heads will roll. 5 raised to the 6th power is 1 over 15,625. 15,625. Ooh, that's a great number. Okay, so that's method 1. Method 2. The other way to approach this, which I think is less popular, which is why I'm doing this one second, but you might say you like it, is that you subtract to bring them together. What does that mean? Well, remember when up here we added the exponents when we multiply? When we divide like this, we subtract. So what we could do is we could bring them both up on top. So I've got the -2 that's already up here, and I subtract the 4 that I'm moving. And again, if I move everybody, I leave a 1. So that's 5 to the -6 over 1, which is 1 over 5 to the 6th, which is 1 over 15,625. Or I can take 5 to the -2 all over 5 to the 4th, and I can choose to move them into the denominator. So I have 5 to the 4th minus the -2. And that equals 1 over 5 to the 4 plus 2 equals 1 over 5 to the 6th, which equals 1 over 15,625. So for this one, you actually have 2 methods, but really 3 ways to approach it. So again, there are always going to be lots and lots of choices. And it may be, I'm going to guess that this is going to feel a little squishy for a lot of people. Ask for more practice. If you don't get enough practice in the homework, ask for more. Say, I would like more problems that look just like this. And I'd be happy to give them to you, or a tutor could give them to you. Okay, so the last part of this that we're going to do for this video is that we're going to go over the power rule for exponents, and then we will continue this in the next video. So let me just introduce this for this video, and that is the power rule for exponents. So what does that mean? Well, it means that if I have 3 squared to the 4th power, what does that equal? Well, that's going to be 3 squared times 3 squared times 3 squared times 3 squared, right? There should be 4 of them, right? Because it's 3 squared to the 4th power. So should I just add the 2 and the 4? Do I get 6? And the answer is no. Take a look. I've got 3 squared times 3 squared times 3 squared times 3 squared, which equals this, which equals 2 plus 2 plus 2 plus 2, right? Using the multiplication rule, which equals 3 to the 8th. How do we get 8 from 2 and 4? We multiply. So, what's the formula? The formula is if you have a to the m raised to the nth power, you multiply the exponents as long as it exists. So what does that mean? Well, very quickly, 2 to the -1 to the -2 is going to be 2 to the -1 times -2, which is 2 to the 2 negatives multiplied together, 2 squared. Why does this make sense? Well, so 2 to the -1 is a vampire, right? So it's going to go down the denominator. But then if you raise it to the -2, it comes back up, right? So every negative is going to pop it upside down, and it brings it, so 2 minuses, it goes down, and then it comes back up. 3 minuses would put it down in the 4, bring it back up. 5, down the bottom. 6, bring it back up. Okay, so what's happening here? I've got an x to the negative fourth to the fifth power, x to the negative fourth times 5. That's x to the negative 20, which is 1 over x to the 20th. Now, why is it in the denominator? Well, let's take a look. That negative right there took it and flipped it upside down, and then the 5 doesn't flip it, so it stays in the denominator. Just like that. Woohoo! Okay, so we've just hit 30 minutes, so I'm going to go ahead and cap this video now. There's one more video for this section, and so, but it's been 30 minutes, so definitely go take a break, do something else, talk to people, play music, go blink out in the sun, get some vitamin D, eat some vegetables, have some snacks, play a video game, whatever it is that, makes you happy, and know that you're amazing and awesome, and you made it through my very strange vampire video. And, you guys are awesome. Math on. Woohoo.